welcome to my talk on the practice of chaos engineering, and more specifically, the practice of running game days, particularly for those of you who are newer to site reliability or resilience engineering. So just a little bit of background about me. I'm a senior engineer at Teachers Pay Teachers, and I've been there for about a year and a half now. So this talk is a compilation of some learnings during my time at TPT, since I focused a lot on site reliability engineering as both a tech lead and an IC software engineer. So before diving any further, I'm going to give a quick run through of what we'll cover today. So first, I'll start with just basics of chaos engineering for those who need a refresher or might be newer to this area of SRE or DevOps. From there, I'll transition into talking about the beginning to end experimentation cycle. After that, we'll be done with the sort of background portion of the talk and head into the main reason y'all are here today, which is to talk about game days, getting started with game days, and the types of game day models that you can implement. So that's a lot to cover, so let's head right into it. So even though some of us here already know what chaos engineering is, I want to start with just providing some shared language and definitions for the rest of this talk. So we'll begin with the very core question of what chaos engineering even is. So I just finished saying a couple of minutes ago that I'm very excited about thinking about what it means to create and manage production services. Service management has grown enormously in complexity over the last decade, primarily because of the explosion of microservices, as I'm sure you're all familiar. And so what it means to manage a service and specifically manage its reliability isn't prescriptive or straightforward as it used to be. So it's really up to us engineers to figure out the best practices and methodologies for managing the services that we own. So that said, the way I think about chaos engineering is that it's one of the tools that we can use to manage our production services. So I think when people think about managing services, they tend to jump to maintenance or mitigation, two modes that are absolutely table stakes requirements for service management, but also not the full picture of what it means to manage a service and especially manage a service well. So to manage a service well, we have to sort of change the form of thinking that we're used to. So we have to incorporate this new mode of thinking, which is a more proactive one. So as folks who are in the DevOps or platform engineering world, our focus is more on enabling other engineers to deliver end user facing features rather than delivering them ourselves. So one of the ways that we can do this, and I think is a principle of DevOps in general, is taking on the cognitive load of what it means to be an engineer. And the cognitive load in this case is the cognitive load of proactively managing services. So with that in mind, I'm going to expand this definition just a little bit, since I did start to provide a definition, but also didn't actually provide a concrete one. So to put it more concretely, chaos engineering is the discipline of experimenting on a system to build confidence, and specifically to build confidence in its capacity to be resilient in production. So to give you some more color here, the confidence that chaos engineering provides isn't necessarily redundant to the other practices like testing. I think that's a common one that folks ask about. So testing as in unit tests, integration tests, end-to-end tests, etc. Again, table stakes for creating and managing services, but it is limited in that it's really only simulating service communication, right? And reality is much more complicated than that. And it's really hard to simulate the conditions that actually might happen in production. So instead of going down the sort of hopeless rabbit hole of trying to simulate real world conditions, chaos engineering sort of flips that on its head. And it flips that on its head by embracing the conditions that already exist, and more specifically by embracing a form of testing in production. So yeah, and instead of testing, we call it experimentation, because we try to reserve testing for, I think, more predictable circumstances, and it sounds cooler. So yeah, so experimentation, again, is sort of the core language of chaos engineering, and it'll greatly inform how game days are run. I'm going to spoil what it means to run a game day a bit here, but game days are basically the process implementation of the experimentation cycle. And because of that, let's make sure that we nail down what the experimentation cycle looks like, so we can actually apply it in how we run game days. So like I mentioned, the point of this type of experimentation is to build confidence in how our systems work. And the insights that come from these experiments help us refine the mental model of how our services work together, so that we can not only build resilience into our actual systems, but also build resilience into our ability to manage or mitigate our systems. So there's both the like sort of human, both the actual like system component, but also the human component of actually being able to understand and analyze our systems and how they work together. So each time, and especially over time, right, each of these experiments sort of creates a form of foresight that's, I think, really hard to get elsewhere. It's definitely not possible through our regular testing modes. So I think this is like where the uniqueness of chaos engineering really shines. So this cycle I keep referring to, well, let's talk about it. So let's take us down a little bit of a memory lane. Do you remember this? I think I learned about this in like elementary school, the scientific method. It basically formalized how you're supposed to go about experiments in a scientific setting, right? I won't regurgitate the steps here because you can see them here, but basically it encompasses 6 different stages, each of which like loosely translates to a part of the chaos engineering experiment cycle. So translating this into our context, we begin in a like sort of similar ambiguous state of observation. This observation portion here doesn't and probably even shouldn't have to be that formal. As engineers, we're like constantly observing our systems every time we contribute to our code bases, debug a production failure, use our observability tools, etc. We're building up the mental model of how our systems work. Even if we aren't actively thinking about building that mental model, we ultimately are. And over time, right, assumptions get built into that mental model without even realizing it, without doing it purposely. So sometimes, you know, these assumptions are accurate, but when they're not, right, this can lead to production incidents, right? Whether it's we deploy a bad change, design our architecture in an inefficient way, etc. So yeah, this knowledge we accumulate over time is really what should be guiding the questions we want to ask and test in production. So it should be really guiding this like first step here. The best way I think to form a chaos engineering experiment is to ask the question like, what would happen if, and then answer that question with explanations as to why. So, you know, what would happen if all of our Kubernetes pods terminated suddenly? And the answers to these questions are your assumptions. These are the assumptions that you're making about how your system works. So ideally, the way this sort of experiment cycle works is it's usually collaborative, which I'll get more into why that is and what that looks like. But you know, in a sort of collaborative setting, right, you should probably have a pretty healthy list of assumptions at the end of like this sort of exercise. But once you have that healthy list of assumptions, right, you do need to prioritize it, right? Like obviously you can't test all of these different assumptions. And I won't go into the prioritization frameworks now, but particularly because I think Gremlin does a really great job of describing their prioritization framework here. I definitely encourage you to check out this link listed right here. But really the point is that like when you're planning an experiment, you should have a framework for prioritizing which assumption or assumptions you want to test first. And so once you've narrowed down, once you've identified sort of the scope of your experiment, and we'll go into details as to like later as to what the right layer of scope is there. But this is when you can actually begin to design the details of your experiment. And this includes details like what scenarios would actually reproduce the questions you asked to define assumptions, and which tools will enable you to do that in a safe way. So in my Kubernetes example with the terminating pods, right, you could use a tool like kubemon to simulate that condition in production. So this third phase here, there are many chaos engineering tools out there. Too many to list. I just mentioned Chaos Monkey, and there's kubemon. as an example of a tool that I've used at TPT for a few game days. And this is why this like research component here is super important. There's plenty of tools that you have to look into to see if like is what you're actually wanting to test even possible to simulate in a way that's easy to revert. Because ultimately, while we want to encourage experimentation, right, we do want to do it in a safe way. We don't want to cause a production failure and then not have a way of like reverting back quickly. So this is something that you definitely want to have guide your this sort of research phase. So the other part of this, right, is to like actually lay out your hypothesis. The hypothesis is really sort of formulated already in this first step of the observant question. So when you're answering the questions that you come up with, the answers or the assumptions that you have are ultimately your hypothesis. So it's more just like the formalization of that hypothesis, especially in the context of like the actual experiment that you'll be conducting. And by the end of this step, right, you should ultimately have a solid plan for like what the experiment is going to look like from beginning to end. You know, what tool are you using? What's the timeline agenda? What roles, etc. And then we get to the fun part, right, which is run the experiment. And again, like the important part here, right, is that you should be running this experiment in production. This shouldn't be on a staging environment. You're not going to get the same value out of it. Staging it's really hard to simulate the same kind of user traffic you'll see, both in its variance and like volume, though volume is actually the easier part. The variance is actually where a lot of value is added from testing in production. Yeah, so even if, so once your experiment runs, it could go a number of different ways, right? It might go perfectly smoothly. It might lead to an incident. Whatever it is that happens, there's a lot of value to be extracted from this experiment. So even again, if your experiment runs super smoothly, right, there's still a way to, there's still one confirmation of whether you were right or wrong with our like sort of steady state hypothesis. And you should conduct it in a similar way that you would like conduct a postmortem. So this experiment the experiment that you ultimately end up conducting should really look exactly like it would process-wise in terms of like an incident, even if there isn't actually like large impact or whatnot. So much like our typical incident reviews, there should be a focus on like determining root cause if things go poorly. And it should be answering questions like, you know, how did the experiment scenarios impact our steady state criteria? Did they impact them in the way that we thought? How were they different? Was there impact on our systems that we didn't foresee, and why was that?
Hi, we are Eficode and we organize the DevOps conference. DevOps is not a role, it's a way to increase an organization's ability to deliver applications and services faster with better quality. Some people say that DevOps is a management science. If Agile and DevOps are not yet part of your whole organization, we would love to have a chat and discuss how to make it real for you. You can find us at eficode.com. The links are in the description. And have a great time with the DevOps conference talks.
And this last part, again, similar to incident reviews, action items should be like clearly stated. There should be owners assigned, right? And I think the most important part here, though, right, is obviously these action items will allow you to build more resilience into your system, right? But I think it's also just important to be sharing out findings with others, right? Sharing your learnings with others across your org, across your team, whatever the context is, I think is like one of the greatest value adds here. So now we go more into game days, and specifically, you know, game days at different scales, so to speak. So regardless of the game day implementation you land on, and we'll go into like what those look like in a minute, they should all still have one thing in common, which is that they should serve the purpose of building foresight through community. For most of us here, that community is, you know, probably our team, maybe our eng org all together. It depends on, you know, how small, large, what's feasible. And yeah, I think this is really like the sort of, again, like the human component that's been a theme of this conference so far, is it's not only about building resilient systems. It's also about building resilient engineers, about building resilient teams who manage our services. So at TBT, right, we have a culture that emphasizes learning and growing together. And so this sort of game day model fit in super nicely with us. And again, game days I think are a way of are an opportunity for us to grow this resilience together, learn from each other, etc. And I think this is particularly important because this is in the name of like probably one of the most stressful parts of our jobs, right? Incident management. So yeah, I think there's a lot of benefits here, and I'll go into some more here. So starting off here, right, the first, I think, sort of benefits of running game days at your company or team, whichever context, right, is again, like this concept of building collective wisdom, right? Like you're not only building wisdom for yourself, right, but you're also building it with your team. You're making sure that your mental models are matching instead of conflicting. I know in game days that I've run at TPT, there's definitely been many moments where we were sort of negotiating like, oh yes, this is how I think it would run versus like how it would actually run, or that. And I think that sort of healthy discussion is super important, and some of the best moments in terms of learning from my coworkers and whatnot. Second here, right, is like it reduces silos, and a sort of similar theme as the first one here, right? Like when you build collective wisdom together, right, you also build each other's skill sets and reduce like knowledge silos that might be existing in your company. And DevOps, one of the principles in DevOps is about reducing silos. So I think this is again another way to sort of mitigate the silos reductions in the context of your org. And then lastly, fostering psychological safety, right? So I mentioned that like a lot of the sort of practices in chaos engineering follow very similarly as to like incidents. So how you manage incidents, right? The postmortem process, right? Similar to incidents, right? Postmortem should be blameless. There should be collective ownership here. And I think this is a great way of like fostering psychological safety within your game day team or within your experimentation team. So going into those more specific game day models, sorry, I'm just going to check the time. Okay, cool. Yeah, so starting off with the game day models, right? So when I mentioned scale here before, what I'm referring to is actually both in terms of like the actual scale of experiments in our systems, right? So how many services are we experimenting on, et cetera? Those sort of like more technical questions, right? But I'm also referring to like the scale of our organization. So, are we running a team-wide game day? Are we running an org-wide game day? Are we running a multi-team game day, et cetera? So these are all the questions that like you want to answer when you're designing your experiments. And they're also like the limitations that are going to be placed on which type of experience you can actually conduct. So for example, right, if you're working on a game day for your specific team, right, you probably can't inject chaos into services that you don't own, or at least you shouldn't without permission. And so I think these are again some of the constraints that you have to consider. But I think for those of us who like starting out, especially, I think it's great to just start off with like a small core team. I don't think it has to be, or you don't have to start off with an org-wide game day. In fact, I think it's often more effective to start with the smaller team, and that what that team can, who that team can encompass can vary, right? It could be your team specifically. It can be different members of several teams, etc. But I think the important part here, right, is like that you really build a strong foundation, both because there's a lot of, I think, learning in this process, but also because it's a great way, I think, of sort of a sort of good bottoms up approach to like scaling this sort of culture of experimentation at your org. And I think I mentioned already like psychological safety as being like an important tenet here. And I think if you start off too wide in scope, it's hard to really like have that assumption of psychological safety, especially if it's with coworkers that maybe you don't know as well. So that's why I think starting off with a small team is like a pretty good strategy. It's much easier to build psychological safety in a smaller team, and once you have that strong core, you can actually scale it out to the rest of your org. So assuming once you've gotten past this sort of core team approach, right? Maybe now it's time to actually expand. You've maybe conducted a few experiments with this core team. Maybe again it's on your team. Maybe it's multiple folks across different teams. I've done both, and from there, right? Like now you can start evangelizing these practices across your organization to other teams. Some tools, I think best practices here, right, is like make it easy to adopt for other teams, right? Like put together templates, put together experimentation plan examples, docs, etc. All these sort of scalable materials, so that way, like teams that want to adopt into it just can. And I think that strategy has definitely served us well when we were evangelizing chaos engineering at TPT. So it's one I definitely highly recommend when getting started with this sort of work. And then sort of this last mode, right, is once you head towards a more org-wide. Again, constraints here will be, how large is your org? But generally speaking, right, like the concept of having a just wider scope experiment here, it is a lot harder to manage like each of the pieces of this, right? Like there's going to be a lot more overhead in terms of logistics, right? Planning the right days, right? If you're planning around like delivery days, deadlines, etc., availability, etc. So this is definitely one thing to be cognizant of, is the sort of like extra overhead that comes into play here. But it is also like a very powerful way of like enforcing this culture of experimentation, and also like being able to learn from coworkers that maybe you don't typically interact with. Again, limiting those knowledge silos that might already exist. So yeah, I think again here, I think same strategies as mentioned before, right? Having scalable resources to make it easy to start a game day, and having just I think a very clear cut like timeline of what it looks like, and following again this experiment cycle from beginning to end. Though what it looks like, it might differ depending on the scale here, especially given the scope, right? When you scale out more into the org-wide portion of a game day, your availability to like actually tackle multiple services at once widens up. So I think we're running just out of time here, so I'm going to just wrap it up really quickly. Just some final references. I already referenced the Gremlin doc. Their docs are awesome. Highly recommend checking those out. So yeah, after talking to you about like importance of communication, of community, and learning through chaos engineering, I figured I'd give some shout outs. So the Gremlin team, Nora Jones for her awesome book on chaos engineering, and of course, nevertheless, the Google SRE book.
Thank you, Lesley. So we have a question for you. It's in the chat, and I would encourage everyone and the participants to go to the sessions. Under the sessions Q&A, please do ask your question there if you have any. And if you find any question interesting, please do upvote. So I'll read up the question. It says, how do you build confidence in chaos engineering? How do you build confidence in chaos engineering in a culture that is afraid of breaking production? Often when companies have attitude like, why break it if it's running? So I think you've answered your question by saying, start with the core team and expand. But is there anything else you would like to add to that?
Yeah, no, I mean, I think that's a great point, especially because in orgs that are larger, right? Like the culture around that sort of hesitancy can vary a lot. And I think so. Yes, I think starting out small is definitely a great way, because yes, getting organizational buy-in if you're trying to do it org-wide is like much harder than getting buy-in when you're just like a team of 5 wanting to conduct an experiment. So I think that's like one strategy, is like why I think it's one of the reasons why this bottoms up strategy can be really effective, right? is like you're leading through an example essentially. And it's harder to, again, lead through an example when that like scope is too large. I think when you start off with a small team, like there's less permission that you have to ask for. So I think that's why that's been a good strategy for us. I think, another thing here, right, is like it's easier, I think, to like, if your entire org is like one that has a culture of like hesitancy around breaking production, if you're like a tech lead or a senior engineer, right, it's easier, I think, to like embrace the brokenness that is production. So, I think you as an individual can also sort of lead in that way as well, since, yeah.
Cool. So another question coming in. Could you explain a bit more or give an example about using GameDays to build resilience into teams?
Yeah. So I don't think I mentioned this in my talk, but I mentioned a lot about like the testing scenarios in production, right? And testing your actual services in production, but it's also because this is in production and it's like a more real world use case. While there should be a way to like quickly revert the experiment if it goes too poorly, it still is like a way of like practicing your actual like incident management skills and your actual like ability to debug production systems. So I think like in that exercise, right, like you build resilience as an engineer to like incidents that might happen in production. So I think it's a nice way of like refining that skill set that's hard to refine in a more practical way, right? Because like you don't want to necessarily. It's just hard to, I think, like simulate like debugging debugging a system without like a concrete example. So this is just like one way of doing a concrete example. It's also why, as part of like on-call, as part of on-call training, chaos engineering experiments, I think, are a great strategy, because again, there's like an easy way to revert. So there is like less stress, but it still is somewhat stressful. So I think it's a nice like sort of intermediate step for folks who are training to go on call before they actually go on call.
So when I read here in this case, resilience into teams, I also was thinking a bit about buzz factor. So how can you use GameDays in this case to kind of reduce buzz factor, like detect buzz factor?
Yeah, definitely. I think like the silo reduction one is probably the most obvious case. Like I think for us, we had a lot, like a very good like cross-functional group as our initial core team. So folks from like different product teams, folks from different platform teams, etc. And that was great because it just like allowed us to expand our skill set in ways that we're not normally exposed to, which like decreases like the dependency of relying on like a singular person or even a singular team.
I heard you mention about having an expectations of what is going to be broken if we go and try out the experiment on this particular thing. But reality might be different. So do you have suggestions for tools for like recording expectations and reality? And further to continue with the question, maybe some templates to record results and do knowledge sharing.
Yeah, yes, I think so. The templates I have are ones I've created mostly. There are templates. Gremlin does have templates themselves, so I encourage you to check out their templates as well. I think the important thing is just like you very concretely list like, this is what I expect from beginning to end. So like totally outline the entire scenario. And then I think like, during the actual experiment, right, like you should have sort of in the similar vein of like incident management roles, right? Like you should have a scribe, you should have, the incident commander, etc. So the scribe should also be recording like as many things as possible. And then like in your more like post-mortem ritual, so the actual meeting, like after everything's resolved or whatnot, like do that concrete comparison of like what did we expect versus like what was reality.